Well, hello everyone, and my name is JJ Asgar, and thank you for joining us on the IBM Developer Twitch channel today. Normally, most of these are reaching in the afternoon, but today I am very privileged to have two friends from the Z and Systems org for IBM. Hendrik, are you there, buddy?
Yep. Hi, everybody.
Hi, and Willie, are you there?
Yeah, hello everyone. Hi JJ.
Hi. So yes, we are going to be talking about some interesting technology based around that IBM runs called Linux Z or LinuxOne. Now we're going to actually go really deep into this. I know very little about this, so I'm gonna ask some very interesting questions. But Hendrik, how about you introduce yourself real quick, just so our audience knows who you are?
Yeah, thanks, JJ. My name is Hendrik. I'm working more than 15 years on the IBM C and LinuxOne platform in a couple of roles, from my focus on engineering, working with customers all around Linux on C and LinuxOne, as well as since a few years with Red Hat OpenShift.
Nice.
Up to you,
And
Willie.
Okay. So hello everyone. My name is Wilhelm. I'm working since a long time with IBM, but I can tell you, computing is my life. You know what? I started with the ZX81. Working on a basically on a piece of paper and dimension, and then I got to the mainframe, and I said, what? Wow! I'm getting to the mainframe to do programming. And that the part was very interesting, because you get there and then somebody tells you, you do programming, but if you do a mistake, you know what, the banks cannot deliver money tomorrow anymore. So that's exciting. But other than that, I'm working with customers worldwide. So I traveled the world thanks to IBM, giving me the opportunity and the chance to have, in this profession, such, big contact or tremendous work. So yeah.
absolutely. Wonderful. So we've got a handful of people watching us, so I want to make sure that I say this out loud that we are in a little bit of a delay, but we would love to answer any questions or thoughts you have. So please don't hesitate to throw them in the Twitch chat there. I'm paying attention the best I can to make sure I can bring them in. But let's just start off from the very top here. What is Linux Z or LinuxOne? Like, I know Linux, I know I use it. I use it pretty regularly, but what is it? Like, why is it? Why is it? Tell me, as someone who comes from the x86 world, why I should look at LinuxOne.
Well, I like that. Coming from the x86 world or coming from the PC world, um, back in the years, IBM decided to build a machine for computation, and they called it System 360. And
Okay.
that means it can do all the work 360 degrees of a circle, right? So that's everything you
Ah,
can do, from industrial work, from booking, from calculations, all that. So it was designed in the 60s,
okay.
and it came out in 1964. So basically, we are talking here about many years back. But I keep saying, at the same time that this machine came out, a car came out which is famous today, still very famous, and that's the Porsche 911. So basically, we keep hearing, the mainframe. Oh, that's an old technology. If you look up the Porsche on the street and you tell this is old, then you can say the mainframe is old. That's how it developed, right? So that's why this mindset is so interesting. Yeah. So and I think, with that doing this 360 work, you could do everything in that time frame, but everything was not everything in the new world in the 90s and near the 2000s, when the Penguin came along. So Linux came along, and Henry can tell a story about that. I think, the Penguin became, found a house in the mainframe.
Yeah,
I
and
like that.
I,
I like an igloo. It got an igloo inside the
Yeah,
mainframe.
yeah.
and I'm basically one of those penguins that worked heavily on the Linux side and the kernel side. And Basically, the first impression I got from the C was during my studies, and was really fascinated of the power and scalability. So that's why I joined IBM, and was really focused on IBM C. And it took a while to get to the core with the Linux team, to start working on the Linux kernel and getting more and more insights into the Z platform.
So let me ask. We all know the Linux kernel is written in C. It's arguably one of the largest C projects on the planet, right?
Right.
Can you write just C to talk to Linux? Z? Wow, that's confusing. Can you write Charlie to talk to Zebra? Like, can you just write C code to talk to Z, or do you need to write in a different language to talk to Z?
Over the time, meanwhile, it's mostly C. In the beginning, there were some more assembler particular pieces, but we also have the toolchain team, compiler, and so on that worked heavily on the back end and optimization. So these days, you have really languages like Go and Rust running seamlessly on the mainframe.
So Hendrik, wait, Hendrik, you're a wizard? Is that what I'm hearing? You're a wizard of like all the different languages to understand all this stuff.
Not me alone. It's an entire team, and it took time.
Okay.
I mean, it's 2 decades when we started Linux on the mainframe.
Nice. Sorry, Willie, what were you saying?
Well, yeah. What I wanted to say is, when the penguins started coming to the mainframe, everybody thought, it might be very complex. It might be, you need to rewrite. Well, it wasn't the case, because a couple of colleagues found out during weekend work that they could recompile the kernel for that platform without doing changes. So what they needed was the GCC compiler, and that compiler was adjusted, and that's it. That's awesome. So basically today, this the code change is about 2% to 3%, and that's it. So that's amazing how this platform, coming from those years, could adopt this new technology, starting with Linux. Well, these days you're talking, right, open source and all these new technologies more. Yeah.
Yeah, indeed. From a Linux kernel perspective, the C platform code, it's just 5%.
All right. Okay. So as we keep going down this conversation, what is S390 exactly? I've heard this term before, and I assumed it was a car, but obviously I was wrong. It was supposed to be a joke. So we have the S390, which is the chip. Yes, but that's different than the PPC, right? Or the PPE 64. Like, can you give me a rundown of all this so I understand this a little bit clearer?
So the very interesting part here is I did a presentation at the New York Stock Exchange, and then there a client asked me, is this machine, or is the processor in this machine a special Intel processor?
Okay.
That was a question, and I found it very interesting, and the answer is no. It is a total different architecture. Okay. The point is, computing can be done in different ways, right? And these days we have ARM, we have on x86, we have already different manufacturers which are doing processor, Intel and so on. But with S390, we called it System 390. Remember the 360 degrees? Well, yes. The evolution came to a System 390 for reason of evolution that they came along with that name. But it's a system, an integrated system that is able to run different workloads, and that's why it changed over time. That's why now it's called Z, because of the characteristics having a zero downtime. We have 50 years before 50 years mean time before failure. So therefore, it is the characteristic of the machine. Almost everything is done redundant in that machine. That's why Z, System Z, zero downtime. It runs around the clock, 360. We have customers which do not restart that machine over years. Can you imagine that?
As long as you got power to it, it's working, huh?
Well, that's correct. Well, it needs power.
So we got a comment here from T Bloom Q. This is not a C or C++ issue. You must have binaries that run on the S390
Yes.
ISA, which is different. Do you mind kind of filling in some more detail around that for me?
That's what I meant before, because the the compiler was GCC, the GCC compiler was changed so that you run that code through the GCC compiler and produce the code that is running on S390, right?
Got it. Okay.
But you do not need to touch that code. So the code that is running on x86 is compiled for x86. And that's why taking that code, that source code, and running it through the JCC compiler on the mainframe, on Z, you produce that code that is running then there. That's how simple it is.
Yeah, so for my x86 home lab world, it's the difference in me running something on my Mac and my Raspberry Pi, for instance, where I have to recompile something to get it to work there. Got it. Okay, so it's the same source code. It's just running it through a different compiler to get it to show up. That makes so much more sense. And now because of Linux Z being zero downtime, when I send my code up to that machine, because I pushed it through the compiler, now, assuming again we have power, it works. It works all the time. That's great.
Yeah, well, absolutely.
I live in Texas, so we might have some problems with our power.
Oh, really?
So, yeah. so I'm allowed to make that joke. Anyway. All right. So I kind of get. So Linux is just Linux. That's the core of this whole story, and this is great. This is great. Okay. So you were talking about how the Porsche 911 was like, it came out the same year. It's a gorgeous car, the same technology around it, and now we're in the future, and we're running now Linux Z, Linux. Okay, actually, let me take a quick step back. Can I use Linux Z and LinuxOne in the same understanding, or is there actually a difference between LinuxOne and Linux Z?
Wow,
that's a super question. Well, let's call it IBM Z and IBM LinuxOne, because that's basically the hardware. It's like it's the hardware. So your IBM Z machine, that is basically, that was made or is from an evolution to host or to run hybrid workloads. So you can run your banking application that was developed in 1970 something, and guess what? We have many customers and clients that are running applications from the 70s. So the compatibility is the major point here. You can run those applications even on newer machines. So that's number one. Then we saw that clients are very sensitive on what is meant with such platform. So that's where from a market perspective, IBM LinuxOne was born. And IBM LinuxOne is for Linux only workloads. Now we have the biggest banks in Japan and in South Africa running Linux only, in Brazil running Linux only workloads on these machines. It is the largest scalable server right now. So therefore you can scale up to 8,000 virtual machines. You can scale out over 2 million containers these days, when you're talking application containers, in one single machine without buying a new hardware. And you can scale, and the scalability is the major characteristic, scaling vertically. So not horizontally as you do it on an x86, you add a new server and a new server, or a new blade and a new blade. In this case, we're just enabling capacity, and you can enable and disable capacity on demand as you go.
Interesting. Okay, so Willie, I want to just pick on something you just said there, and
Absolutely.
I'm kind of curious. You just said that the banks out of those 3 countries all rely on Linux and also IBM hardware to run. Are you saying, without saying, that the world runs on IBM and we just don't realize it? Is that what you're saying?
Oh yes. Every day you wake up and you even don't know that in the background what you're doing, what you're using, most probably is a mainframe. And I'm saying, waking up, going to just switching on the lights. because the power companies, most of the power companies are using mainframe in the back.
Probably not.
Then
in
you
Texas,
go,
though.
you know what? You go for a shower then, right? You turn on water. So water preparation and water is done and is managed. The management of the water companies are using mainframes in the background. So these, not many people are thinking of that. What happens and how many of these processes are done in the background before you get to that point where you just go and get your water, right?
Nice.
And so on. So basically, we talked about banks and insurance companies, and that brings me to a point where I had a student class. They asked me, who needs a mainframe these days? Why is a mainframe these days important? So I said, you know what? If you have one application and you want to have one machine with this application, and at the same time you want to have over 100,000 users at the same time accessing that application, then you most probably run very well for a mainframe. And we're talking 100,000. I have customers having 500 million on a machine.
That's
okay,
crazy.
so we're talking about dimensions. It's unbelievable. And talking about dimensions, it was the machine that was starting Apollo 11, brought the people to the moon and back.
Right.
That's right. That's right. That's
So
amazing.
that's from history to now. It is really amazing what we see. And yeah.
So Willie, no, don't get me wrong. Like that is phenomenal. Like but when you start thinking about the scale and the unbelievable, like how much our life really does rely on the backbone of the world, right? Like it's the backbone of the world. Yes, okay, cool. We have cloud and stuff like that out there, but I like the idea of fresh water and power, right? Like that's kind of important. But okay, so I'm just an engineer. I'm playing in the cloud space. Hell, I'm on IBM Developer on Twitch right now, right? How can I even like I'm hearing you say all these things and I want to break into this world. Turns out, you know what? I actually want to spend a little bit of time understanding this world a little bit more. Where can I go? What can I do? Like, is there a way I can get access to it without spending $7 million?
Sure.
Oh,
well,
really? It's just
go ahead. Yeah.
There are ways. Yeah, we have C and LinuxOne servers available in our so-called community cloud. You can register there, get access to it, and even since a few months, you can also use Red Hat OpenShift there and try it out.
And you know what? You don't even need a credit card. You do not need a credit card. It's for free.
I was actually about to ask that question where I was like, well, cool, but when am I going to be charged? And then also, like, as you said, I have access to it now, but what can I do with it? Like, can I just like spin up Nginx on there and see a website?
Right.
Or can I like actually, like, just so I can feel comfortable? Is it a place so I can learn to feel comfortable in that space? Or can I go deeper than just using it as like a VM? Like, what can I do?
So the community cloud provides two things. One, of course, you can get machines virtual machines on the LinuxOne, where you can get a feeling how this Linux feels like on LinuxOne, and in 99% it's the same as on other platforms.
Okay.
And with if you want to go into cloud native development, you can get a project on OpenShift on LinuxOne Community Cloud. And there, for example, you can deploy an Nginx. If you like, I can show you.
Yeah, actually, that would be great.
That would be great. So then let me.
And we can share the link if somebody wants to access it. So as well.
Perfect. Yeah. So Hendrik, spin that up. But while you're doing that, interestingly enough, we had the statement here by F. Miranda. New Zealand is well invested into carbon neutral policies, so more effective hardware is key for them as well. So being that Linux is Linux Z, or sorry, is the Z processor more efficient? Is it actually better for the environment to do compared to something like x86 or something like ARM? That's a reasonable thing to...
It is working differently, and because of the structure, because of the architecture, we say today you can count about 1 to 10. So basically 10 cores on x86 workload can be done with one core on the Z machine. That's how efficient they work.
Say it one more
So
time.
it's 10 core
10
of an
core.
x86 machine as a workload that runs on that machine. 10 core workload can be consolidated or can run on one single core on the Z machine.
That is significantly better. That is significantly
And you can
better.
imagine now if you have huge databases that needs 100 cores,
Yeah.
and you put them on the Z machine, you need 10 cores. Instead of paying 100 licenses, you pay 10.
That's also good.
That's something our customers like, as you can imagine. So that's why we see lots of database consolidations on their data.
Awesome. That's great. Okay.
Yeah.
So let's see what Hendrik's got here. We've got a bunch of site up right here. I'm gonna go ahead and drop our little names real quick, just so we can see everything a little bit better. So there we go. Hendrik, it's over to you, buddy.
That's the landing page. If you follow the link to the LinuxOne community cloud, as you can scroll down, you need to sign up. And the one really nice thing to start is there are fast start guides, which you can follow, and there you can get some examples. And let me quickly show how this Nginx thing looks like. But you can also go deeper with air travel, and there are also some guides, and even let me pick one. So if you guides
Wait.
and
Hang on, Hendrik. Did I just see the Docker? Did I just see Docker on there? So I can just throw a Docker container up into this thing too? Is that
sure
true?
You can. You can. I mean, there are guides that helps you to getting started with it, but at the end, it's up to you to develop your application and try it out.
Nice. Okay. Sorry, I didn't mean to interrupt you there. I just saw it and I'm like, aha, I know what that is.
Well, you see MongoDB there, so that's basically it's a lot that you can do.
Hey, it's MongoDB. That means it's a Web 2.0, right? That's supposed to be a joke. It's supposed to be a joke.
It's a non-structured database.
There you go. So so keep going, Hendrik. Let's see.
Okay, I mean, you can log in, and I simply prepare this, and hopefully it works right now. Then
he's doing it live, everybody. He's actually doing it live.
Yeah. Landing page. You have two services. Of course, you can have virtual servers that you might want to create. I mean, just clicking a bit around.
Is that the OpenStack? Did I really see OpenStack there?
That's managed on the IBM and Marist College. I think that they have an OpenStack-based solution, Cloud Infrastructure Center, that helps to provide the infrastructure service. And here, for example, you can select.
But you heard Marist College. So basically, we have colleges which are, teaching the technology. They are teaching Linux. They are teaching the architecture. So therefore, and we have many interests, and even a mainframe contest that is done periodically, and we see an attraction for those classes.
Right. Nice. And there's a mainframe contest upcoming in October. So if you are interested, I can also share that link, sign up, and you do not need any kind of mainframe knowledge to get started there.
Is that the I may have heard this is the master of the it is master of the mainframe. Awesome.
Master of the mainframe.
Awesome. Yep. I went ahead and threw that into the chat also for anyone watching at home.
Perfect. And let me move back here. So I think I leave it up to the audience to spin up a few servers. So let's take a look at the OpenShift part. And it takes a few seconds to spin up the console. Let me briefly log in.
Hunter 2. Sorry, that was a bad joke. Bad joke.
Was it the right password or not? Life is life, I guess.
It happens. It happens to the best of us. Happens to the best. Oh, there we go.
Okay, now we are going. Here we are. That's the project for me. And if you look at this, I already did the instructions to deploy the Nginx. So basically, you have some source code. I mean, that's the deployment. You can look at there. the ports builds, everything is mostly automatically, and you can have the source code, which of course is public, and OpenShift will do the builds for you, deploys the application, and then you can just open the URL and work on it.
That's awesome.
It's
It really is just OpenShift. That's amazing. It really is.
And actually, the guide says 30 minutes. If you have the account, I think it took less than 30 minutes to get it done. So it's quite easy. And it runs on LinuxOne.
Yeah, that's amazing. Like as a cloud technologist, right? Like I spend a lot of time trying to convince people to use Kubernetes or OpenShift or any of that, and now I can actually I can start the narrative where I'm like, well, cloud is cool and all, but when you start looking at the scale that Willie was talking about at the beginning of this, like you needed something to do this. Well, if you're already spending your time with OpenShift, it truly is the cloud platform that just works fine on the mainframes. Like that's what you just showed me. This is amazing. This is great. And this is me actually figuring this out real time. Like this is not me faking it. Like this is me seeing it for the first time, and that is brilliant. It truly is. Wow. All right, I'm flustered. I'm actually flustered. Okay, so what do we want to talk about next? Now that we've seen the awesomeness of it, do we actually want to see what the mainframe looks like, or do we want to go somewhere else? Or do we have any questions? Better yet, from the audience. Do you want to give it a couple seconds for any questions that might come in?
Sure.
IBM help.
Just to be sure that everybody understands, even if you do a flight reservation, you're touching the mainframe, right? Because a flight reservation, imagine in high times. Well, one of the most used or the most interesting applications is flight reservation, booking, flight booking or reservation for hotel rooms or stuff like that, where you have worldwide parallel access and then credit cards. JJ, what do you think? What would you guess? What is a peak of credit card transaction per second in a single customer today?
I would imagine it would be what we call Black Friday here in the U.S.
For example,
where everyone is just trying to use their credit card to get that, really cheap TV or whatever from Best Buy.
How many per second? How many per second would you guess? How many of these transactions per second?
I mean, I'd imagine in the U.S. alone, 100 million. Seems reasonable, right?
So you can 100 million, but that's per second. So in this moment, 100 million.
Oh, sorry, per second. Let's go with 100. Let's go with a million. Let's go with a million. A million people hitting.
So with one machine, we have a customer which measured 20 million per second. 20 million in the time frame that they say 21, right? So in this 1 second, 20 million transactions, and they are secured. Crazy. So they are verified and secured. You cannot do that with another platform.
No.
That's where we are talking. Yeah, it is well, and that's why it is so amazing, right?
That's amazing. It really truly is. Wow. Okay. All right.
So
well,
now
we go. Sorry, Will. We have not had any questions pop in. So y'all were gonna actually show me what one of these mainframes look like. So maybe we hop over to that real quick. Is that cool?
Yeah, sure. Another link that you might be able to share. Are you sharing it, Hendrik? That JJ can. I want JJ to access that mainframe and open it and see what's inside and stuff like that. And we're all virtual, so why don't we do it virtually?
There you go. I like it.
Here we go.
All right. So let me bring this in. Okay. So you sent me this site, which is this one right here, and I'll throw this in the chat too, just to make sure we're all on the same.
And guess what? It is even an app that you can put on your iOS or Android phone, and you can do it on the phone, and you can turn and open up the mainframe on the phone. So therefore, it is really amazing. Yeah.
Nice. I like it. Okay, so we have a few different versions here. So again, we got IBM Z for zero downtime, the Power, which is what Xboxes were made out of at one point, right? Am I wrong about that? That was the power stuff.
Well,
and then we got
yeah. So that's another architecture again, but that's why the world is hybrid these days, and therefore we have multi different architectures and similar. Yeah.
Nice.
So if you go to LinuxOne on this page, are you guiding Hendrik, or should I?
I think we can both do it together. So go to LinuxOne and yeah. And
this one right here?
Exactly. Yep, this one.
All right.
And okay, it takes a bit to load.
Thinking about it. Whoa. Hello.
Now you can just turn it with your mouse.
All right.
Yeah.
I'm moving. I can already hear the data center fans in the background.
Okay, now we want to see what's inside, right?
Yeah.
Absolutely.
Could you try to open the doors? Virtually, yeah. There's something very. Oh,
nope.
Okay.
Go down over here, right? We'll open those doors right there. Nice. All right, so you
see, they're not the same. It's not the same, right? It is. There are different the two cages, and they can be expanded to 4 now. Okay. So basically, you can start with 1, and you can go up to 4. And in one of the cages in the left side that you see here, you see those lower parts, which are the books, which contain the processing power, and the right side contains the connectivity.
Wait, so this is the actual like intercommunication, and these are the actual processors down here?
Yes. Now, nice. What do you think? How many processors fit in one of these machines? I guess.
I imagine the architecture is rather large, so maybe like what, 3, 4?
Well, 190. 190.
Wait, what?
And imagine 190 means equivalent with 1900 Intel cores, right?
That's a lot of math. Hang on, I'm doing it in my head. So this is a cloud. This is a cloud. That's what you're telling me.
Oh, yeah, see, yeah. That's why we say you can do cloud in a box here, right? Yeah. And you know why we say that? Because in one of these machines, you can run much more requests than you do Google searches worldwide per day. What do you think? How many Google searches are done per day?
That's bonkers. Like, seriously, that's a lot of processing power.
Yeah. 5.8 billion are done per day. Google searches. And we can run over 10 billion secured web transactions on a single machine.
On just one of these things right here.
Yes, that's one. Yes, this machine that you see in front of you.
Wow. That's crazy.
Okay, so let's look at the cores. Yeah.
The cores? So the processor drawer, that's what you were talking about?
Yes,
the one that has a...
Well, no, one down. The processor drawer is, yes, that's the book or the drawer. There are two notions that we had with that. And they contain the memory, or part of the memory and part of the cores or processors.
Okay.
Now, if you go back and open and see the one down was the processors.
All right.
It shows you how they look like.
So that's the 190 processors right there.
We're talking about 190 cores. We're talking 190 cores, and they are grouped in groups of 12. So 12 are on one chip, 12 cores per chip. Here you are.
Got it.
And if you click on the bubble there, it tells you that.
Nice. Oh yeah, designed with 12 processor cores per chip, a single. So it's processor. So it's not just my laptop processor running 4 cores. Yeah. This is a 12-core chip with a bunch of processors inside of the core. So it's like a lot of math. A lot of math.
And then you have to add the math, because every single core has a coprocessor which is doing encryption. Exactly. And every single core has a coprocessor which is doing data compression. So you have to triple those cores just to add the coprocessors to it. Before we talk even about the 4 level of cache which is there. So that's a high sophisticated technology that is unbelievable.
That is. It truly,
And-
truly is.
The amazing thing here is that you really can speed up compression and cryptographic operations at CPU speed. So there's just a processor for exactly doing this.
Wow.
And by the way, that it is the fastest processor or core in the world, 5.2 gigahertz. There is no other one that runs on a 5.2 gigahertz speed.
So can I run my gaming server on it?
Sure.
Sure.
just had to ask a question, right? Like,
Well,
run Minecraft on it.
Well,
yes, we have running.
Oh, that's great.
You're laughing, but we had Minecraft running on it.
Oh, that's awesome. That's awesome. That's amazing. Oh, that's so good. All right. So you showed me this one, right? So this is that first one that you were talking about. Like you start here, you go here. Now, are these just larger versions of this LinuxOne here, or what's the different use cases of these?
It's just a model, the smaller and larger for smaller or larger workloads, or scalability. That's the other point. You can start small and then you can grow in multiple of these cages, just putting them side by side.
Got it. Okay. I was curious because I mean, this is like in a car, right? If we're looking at like cars, like this would be like a typical, like this is what most people would be using in the world, or is this like high level, or is this like entry level?
Well, this is, let me say, it's not entry and it's not high. It's just the middle level.
Perfect.
So as I mentioned, these days you can have 4 of these cages. So basically 4 doors, and here we see 2. You can start with 1, and you can have up to 4. And our newest announcement and offering was a so-called LinuxOne Generation 3 Express, which has 1 single door. But that's enough capacity for even smaller cloud providers, or telecommunication providers, or insurance companies that are middle sized. So these it's the capacity is very impressive. Governments are using that. Yeah.
Nice. So Tom here, or sorry, T Bloom just said this. Give me a second here, and So LinuxOne Express, the small box, is the same cost as an x86 with more performance. You don't have to spend $7 million. So there's an entry level.
Yes.
Coming in here. Can you explain?
It is available.
That?
Yeah.
It is
available. That's what I meant before. It's an IBM LinuxOne 3 Express. So it's a Generation 3 Express that was announced a couple months ago, and is available. It's not just announced, it is available. And we see a success with that one because it's the entry level, but not just entry level in terms of capacity. It is more than an entry level capacity, but you can use it as an entry for, if you want to scale with different sites, for example, or you want to just start small and then see how you grow, or you use it as a database server out of your x86. So it's not that's the other point, JJ. You do not need to throw away everything, something that you have. You can just complement or optimize, because on x86 you need a technology refresh every 3 years or something like that. And if you do that refresh and you count that your database is running 5 times better and 10 times more cost effective, you would choose one of these next to your application servers, which still run on your Intel, for example. So therefore, it can be, and it is something that runs together with other platforms as well.
Nice. I like it. I really do. All right. So where are we going to go with this now? We had some. So you wanted to bring in some customer stories here, some actual specific customer stories. Now that we've seen what's going on here, we got about 20 minutes left before we're going to start wrapping up. So, Willie, do you got a good customer story about adoption or leveraging leveraging this technology for us?
I think one of the best customers that I think of that we should mention here is the weather company.
Okay.
Well, you would not think that the weather company would use a mainframe, right? But
No.
think of how many data they need to process and how many requests are coming in for asking about weather, right? And the different types of data, the weather is not necessarily a structured data that has the same structure every time, right? It can be text, it can be unstructured information, and therefore this company adopted first a LinuxOne to have around-the-clock serviceability. That's what we said, before 360 degrees, right? So it runs all the time. And then they adopted open source technology and databases to run on this machine and to have the different areas and different types of data to show them or to use them, right? And that's the beauty of it. So that's Med Office, Meteorological Office, and I mean, it is one of customers which I like very much because they started thinking of, does it make sense? What is about this platform? And they grew and are very happy doing that with it. So that's one of the areas which
Nice.
I would not think immediately that to run with a mainframe, right?
Absolutely.
And then the second one, I don't know, Hendrik, do you have that link as well? Plastic Bank. What do you think about Plastic Bank? Yeah,
Wait.
Hendrik.
Plastic Bank. Well, it sounds very environmental and sustainable. So,
and it's not a bank, right? It's not a bank. It's about plastic.
Right.
And it's about defining plastic not as waste, but as value. And they said they want to grow from 1 to millions of users using and recycling plastic worldwide. And guess what? We have big oil companies which joined this initiative together with Plastic Bank. And that's why, so this link about Plastic Bank and the YouTube about that's amazing. So that's another area which, first of all, looks at the LinuxOne because of scalability, and secondly, it looks because of the trust that you can build with a blockchain implementation. Now I come in with some words here. What is a blockchain, right? So companies which want to work together, not trusting each other, are implementing blockchain because the technology is there to enforce something for untrusted partners, if you want, being part of that blockchain network. It's basically using a shared ledger. You cannot change, you can just add to that ledger information, and therefore transactions that happen are added to the ledger as an information, as a transaction, as a movement. And that's a technology that is evolving as well in all different directions. I mean, again, with LinuxOne, the biggest ships have a consortium with 12 companies that are shipping containers. And these are not application containers. We're talking about goods, right? Containers. And every container needs about 85 pages of documentation to be shipped from Asia to US or to Europe, for example. And that's done out through blockchain without being tampered. Hendrik, you wanted to add something?
Yeah, I think if you are talking about blockchain, maybe blockchain in combination with OpenShift, there was a recent nice press release from Blueberry Gate, which have an immense increase in their transactions per second. So 1,400 blockchain transaction per second with LinuxOne, OpenShift, and blockchain. That's another success story with LinuxOne and blockchain, and of course, cryptographic acceleration.
That's amazing. So and then also, I guess using LinuxOne with the blockchain, you'd be able to have it on your hardware, and you'd actually be able to create, like you said, those 12 different companies, the consortium of agreements. Those are all the different machines that control the ledger, or I guess this, what are they called, the seed nodes or something like that, or the whatever like actually has the node, the wallet in the case of like Bitcoin or whatever. So you'd actually have that all in your own data centers, so you know that that's actually trusted, and then when you get quorum, you know that it is actually the validated stuff, where you know for a fact that it is not random internet thing. It's now actually on your hardware and agreed upon. That is awesome. That really does create like your own like circle of trust.
Yeah.
Right.
Yeah.
And that's implementing. We had a very nice implementation that was done from a food company.
Okay.
And that was called From Pork to Fork.
Nice. I like it.
So from the pork, you could follow the meat until it got on your plate, basically in the restaurant. So that was implemented in blockchain, so nobody could tamper it, and everybody could be controlled from pork to fork. It was very interesting.
That's awesome. That's awesome. That is awesome. That is awesome. All right, so we're coming up to about 10 minutes left. Is there anything else you wanna talk to our audience about or bring up before we start wrapping up?
I wanted to just mention if somebody is interested, and as I mentioned, we have colleges which are teaching this technology and are teaching what's possible. There are several pages, or if you just Google IBM and LinuxOne, you get to the main page already. And if you need classes or something like that, there are different areas that we could point to. On the other hand, Google is your friend, as you can say. You can find a lot, and it's not hidden, right? It is open. And the Open Mainframe project, if somebody would have told me 20 years ago that IBM is doing an open mainframe, I would have said no. I don't believe. I cannot think of it, right? But the Open Mainframe project accepts and ideas and is very open to everything that can be done with or around it.
Yeah, and you can submit your projects, and they will get help and sponsored. And on the other side, there are topics where you can sign up and to work with on mainframe topics.
Nice. Is there like a mentorship program or something like that through all these things, so you can find a community that you can engage with to be able to make sure that you have someone to help you with?
That's as well as available. There are different types of community. For developers, for example, it's a developer community that is available. There's a community available for Linux on Z or Linux on the mainframe and LinuxOne in general. So basically, you can ask any question, and it comes to the development team, and so we distribute that to those which can answer those questions. So there are different areas, or as I said, through the academic initiative, the IBM academic initiative, which we mentioned, I think, at the beginning, can be used there to get more insights. And the last point, I always have another last point. I have something when an 18 years old buys a mainframe, how that works, and that's basically the link for that one.
Okay.
When an 18 years old buys a mainframe, so how he brings it, he disassembles the mainframe, brings it on the truck, puts it in the basement, how he assembles it, how he could. It's a very nice YouTube video as well.
That's amazing. An 18-year-old actually got a mainframe and rebuilt it. Yeah. Where'd he put it?
He put it in the basement.
Oh, in his basement. In his basement.
So that means the other point, you do not need air conditioning. He did not need the air conditioning.
Oh, that's amazing. That's amazing. Oh God. And tell me we hired him. Tell me
we hired him. He's IBM now. Good. He's IBM. Okay. Connor is IBM now. Connor Krukowski is IBM now.
Okay, good. Just checking.
Yeah.
Oh, it's good. It's so good.
He did not let him go. Yeah, he was so enthusiastic, and we were happy to see that. Yeah.
Awesome. Oh, that's so good. All All right,
And the most funny customer I visited, and I told you, I visited customers worldwide. Most funny one was a customer that implemented a data center in a mill, in an old mill where you make your own corn, yeah. And implemented it there, and the cooling was done with water pipes underneath it in the basement. So they had no air conditioning, had about 6 mainframes there, and it was amazing and implement. And they were the only one I saw that powered the mainframe with solar panels.
Wow.
They put solar panels on top of the roof. Of course, it was not always enough power, but they had this dual power implementation to try it out and show that it's possible. That was amazing.
That is amazing. That, with the efficiency and the ability to play off of solar and cool via water. That's an environmentalist's dream right there.
Yeah,
that is awesome. That's great. That's good stuff. Well, cool. Well, let's give the audience a couple minutes to ask any questions if they have any thoughts. I'm going to go ahead and throw in my little line that I always do. If you got any questions or whatnot, we're going to wrap up here at the top of the hour. But I'd love to at least ask Willie or Hendrik a question or two from the audience. So post the question in the chat, maybe. Let's see. And so we talked about mastering the mainframe and how that's coming up in October. Is that a yearly thing, or is it every 6 months? Like how often does mastering the mainframe happen?
Twice a year.
Twice a year.
Twice a year.
Okay. Twice a year. Perfect. Is it like, I'm assuming like winter and summer?
Summer.
Maybe? Summer? Yep. Okay. I'm assuming it's.
And then they have the privilege. They have the privilege if they, the finalists have the privilege to visit the technical university or our technical conference, and and then be celebrated there. So I was already having lunch with 2 sets of the winners from the Master the Mainframe. It's amazing to hear their ideas and how they see the future and how we can build a future, clean and all these new ideas coming from university. Amazing.
Nice, wonderful. So T Bloom is asking, and then we went over this a little bit earlier, but if we can just give it a little rundown again. Can you use the same development tools in Linux, IBM Linux Z as x86? So the short answer is yes, but do you want to go into a little more detail?
Well, it depends. I mean, there are so many development tools available, but if you look from a Linux perspective, Linux is Linux, so you have editors, compilers, and the entire tool chain available. So in that sense, and if you move a stack above with OpenShift, there's also a unified and consistent developer experience. So the toolings are there. If you think something is missing, then reach out to us and we will try to get it addressed.
Great question. Yeah, great question. How do I get in contact with y'all? Like, I mean, obviously I can get in contact with you, but how can our audience, if they want to get a hold of you or to ask you some questions, maybe offline, is there a way to get in contact with you?
Well, there are 2 ways. It's either directly, or we can post the link from our community, from our new created Compass-L community for Linux. I'm posting the link in a second, and there you can get in contact with us. And with us means with the entire LinuxOne Z development test, and therefore it is the way to get your questions answered, no matter what it is.
Perfect. That's exactly what I was hoping for.
This is the link.
Perfect. I will throw that into the chat just now.
And it should bring you directly to the community for Linux on IBM Z and LinuxOne. Compass-L. Community path for Linux. And technology interchange community. So basically, it's for, those people which have questions, ideas, and want to get into contact.
Perfect. Well, gentlemen, this has been insanely enlightening for me. Like, legitimately. I came in here knowing little to nothing about about LinuxOne and LinuxZ, and now that I know there's a difference, that's even more important. I really greatly appreciate your time. And do you have any last comments or words you'd like to tell our audience?
I want to just say thank you. Thanks for being here. Thanks for listening. JJ, thanks for giving us the opportunity, the chance to talk to you and then bring this up, because I think it's a technology, and it's I could tell stories. I can tell you about customers that I visited. It's amazing, from horse racing to cow management and stuff like that, which are very interesting. So therefore, thanks for being here and for having had the chance to be here.
Thanks, JJ, for being here, and it's awesome to read that already one participant make an IBM account. So have fun with LinuxOne community.
That's great. That's
Absolutely.
wonderful. And we really did truly learn about the backbone of the world this week, or during the stream, where it's our mainframes. Like that's what it boils down to. And that's, if anything you've learned from this talk or this conversation, you're using this without realizing it. So, why not learn how to use it better or something like that? I don't know. Anyway. All right. Thank you, everybody.
Thank you.
And
Thank you very much.
I'm going to end the stream now, but y'all stick around. Don't disappear. All right. Bye.
Bye.
Bye-bye.